This thing recording, yes. All right, go ahead. Question.
Good evening, sir. I just want to ask one question before we start. I've been going through your series of videos that you post on YouTube. However, I have not seen a video that addresses projectiles. And I must say, the ones you posted have been very, very useful. I don't know if you have done one for projectiles.
Right. So projectiles we are going to cover today. Right. Projectiles are pretty straightforward. So that's why I
Okay,
left
thank
them
you.
last.
All right, thank you, sir.
So, any more questions?
So,
Yes.
in so you posted 5 days ago. You posted a video, resulting velocity part 2.
Yes.
In that video, you tell us to convert 300 kilometers to meters because they're using meters a second as the velocity.
Yes.
But then for the time, when you say convert it to seconds, you convert it to hours. So I'm not sure if that was wrong or
Yeah,
if you
there
did
was a
it right.
mistake. We did cover that part.
Okay.
There was a mistake. I wasn't supposed to divide by 100. I was supposed to multiply. Not divide by 100, divide by 60. I was supposed to multiply by 60.
Okay, so
So the value we got is correct based on how we were supposed to do it, or based on how I was supposed to do it. Right. But if you calculate the what is this, the velocity as I wrote it there, you would get something different.
okay, so
Right. So there was a mistake. Of which
yes, sir. Understand.
All right, cool. Any more questions?
Sir, for this one, can I ask you if we'll be covering centroids, or if centroids will be in the first test?
Nah, no centroids.
Okay.
All right, centroids we will do in preparation for your exam. Right, so under statics, for both test 1 and test 2, we'll just cover beams. Is it? We good? Hello?
Yes, sir.
All right, any more questions?
Got it.
Right, now there's something I'm not sure if I highlighted, right, regarding what is this, resulting velocity, right? Now with resulting velocity, the wind vector, right? Sometimes they say, or they give you the direction of the wind vector, telling you where it is coming from, or telling you in which direction it is going, right? As you know by now, if they've given you the direction of the wind vector from the perspective of where it's coming from, right, then you obviously have to draw the vector in a direction that is opposite the one you've been given, right? And then if they give you the wind vector from the perspective of where it is headed, then you use it as it is, right? Now, there are cases where the direction of the wind vector is ambiguous or somewhat ambiguous. They don't tell you if it's coming from or if it's going to that direction, right? So in cases where the direction of the wind vector is somewhat ambiguous, then you take it as, or then you look at it as, you take it as it is coming from the direction that you've been given, right? So if the wind vector, if the direction thereof hasn't been given, right? So they haven't said it is going to or coming from. If they haven't mentioned that, then you take that wind vector as if it is coming from the direction that has been given. Are we clear?
So can you make a drawing of what you're talking about?
Right. Maybe first let us look at a question that is similar to what I'm saying. Can you guys see this? What is this?
Yes, sir.
Okay, not this. Resulting velocity. I want us to look at an example where the wind direction is somewhat ambiguous.
Sorry, sir, are you able to rotate perhaps your
Yes, I
screen?
will.
Rotate the page around us.
I will once I've chosen a problem. Right. Okay, from. An aircraft. Okay, let's look at this one. It's not okay. Yeah, let's look at this one. Okay. Right. Resulting velocity. Right. Now let us look at this example, right? Are you still with me?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
So this reads as follows. An aircraft can fly at a velocity of 280 kilometers per hour with no wind interference. It must fly to an airport 275 kilometers north of its current position, right? A northwesterly wind with a velocity of 72 kilometers per hour is blowing, right? Now, if you look at the direction of the wind vector, they haven't indicated if the wind is coming from a northwesterly direction or is going to a northwesterly direction. Do you guys see that here?
Yes, sir.
Yes, sir.
Right. So I'm saying in such cases where the wind vector is unclear as to which direction exactly it is going to, you take it as how it's been given, you take it as if it is coming from this direction, right? So because this wind vector isn't quite clear if it is coming from this direction or going to this direction, you are going to take it as coming from this direction. So meaning when you draw the wind vector on your Cartesian plane, you are going to draw it in a direction opposite the one that's been given, right? The one that's been given is northwesterly. Northwesterly is the same as north 45 degrees west, right? So because they haven't necessarily indicated whether the wind is coming from here or going in this direction, right? You are going to take it as if it is coming from this direction. So if it is coming from this direction, right, it means it is coming essentially it is coming from this quadrant. If it's coming from this quadrant, it means it is going in this direction. So opposite of north 45 degrees west is south 45 degrees east. So essentially the wind vector you would draw in this direction, right? You would draw in this direction, right? And for such a problem, this would be your wind vector, or this would be the direction of your wind vector, right? Are we clear here?
Understood, sir.
Right? So if the direction is ambiguous, you take it as it is coming from the direction that you've been given. Right? The person that asked for a drawing, are we clear here? Hello? All right. Are we
Yes,
clear with everyone else?
I think we are clear, sir. The example is quite clear.
Okay. Okay, good. Wonderful. Right. So I just wanted to make that clear. No? In fact, you can try this one after this session. Right. We good?
Yep, good.
I did send this handout to the group, right? The one with a lot of exercises based on resulting velocity.
Yes,
Show
sir.
us which one, sir.
The one for resulting velocity.
Yeah, I think you gave us some resulting and relative.
Okay. So try this one out, right? Seeing that it is the best example to explain what I've just explained, right? And then maybe look at others as well, where the wind vector or the direction thereof is a bit ambiguous. Right. Any more questions? No questions. All right. So let us look at projectile motion. Right. We're now going to look at projectile motion. All right. Now, under projectile motion, we use what we call kinematic equations, or the term I think you're more familiar with is equations of motion, right? This is where we make use of equations of motion. Now, in N3, we only looked at projectile motion from the perspective of linear motion, right? So it was a projectile that was essentially moving in a straight line, right? So it would go up and come back straight down, moving linearly, right? Now, in N4, we are going to look at a projectile that somewhat moves in a parabolic shape, right? So it moves from where it's being projected, right? It moves in somewhat of a parabolic shape, right, to land wherever it lands based on the velocity, also based on the angle of projection, right? Are we still together?
Yes, sir.
Yep.
Right.
Yes, sir.
As far as equations of motion, right? As far as equations of motions, this is, or these are the four equations of motion, right? Right. So now these we use, as you see, I've labeled these ones as motion on a horizontal plane. So if you're looking at an object that is on a horizontal plane, right, from the perspective of equations of motion, we use the equations of motion, right, as I've written them here, right? And then when we're looking at vertical or motion in the vertical plane, right, instead of what is this, displacement, so S, we normally use H, right? You could either use H or use SY. The Y, so by SY, I mean you could either use H or SY as an S sub Y, right? Indicating that this displacement is on the vertical plane, right? But you could either use SY or H, right? Doesn't really matter. And then instead of acceleration in the vertical plane, we make use of what? Of gravitational acceleration, right? So those are basically the only changes or the only difference between these set of equations which we use on the horizontal plane, right? And this set of equations which we would then use on a vertical plane, right? So these ones we would use, or we used these ones, right, in N3 when we looked at projectile motion from the perspective of linear motion. So where the object was moving in a straight line, vertically, but on a straight line, right? So we would make use of these equations, these linear, what is this? These equations of motion, right? But now we are going to look at projectile motion from the perspective of an object that moves in somewhat of a parabolic shape once it has been projected, right? So we're gonna, what is this? Consider this drawing here, right? When the object is projected at an angle, right, it is going to be projected at an initial velocity v, right? That initial velocity is obviously at an angle, right? And as you know, in order for us to be able to apply conditions of equilibrium, in order for us to be able to apply conditions of equilibrium, we are only able to make use of vectors that are parallel to the Cartesian plane, right? So that is why we need to resolve this velocity, this initial velocity that is at an angle, right? We resolve it into its components. Resolving it into its components, you get the vertical component, which I've labeled here as uy, right? So meaning initial. This is the initial velocity of the projectile in the vertical direction, right? And then, of course, you get a horizontal component of the initial velocity, right, which I've labeled as UH, right? Now, the UH meaning this is the initial, this is the initial horizontal component of the initial velocity, right? Are we still together here?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Now, when we project an object, right, with an initial velocity v, right, as I've said, we have to resolve it into its components, uy and uy being, or u sub y being our initial velocity, initial vertical component of the velocity, right, will be v sine theta, right? Seeing that our angle is a reference from the x-axis, that tells us that the vertical component will be in terms of sine and the horizontal component will be in terms of cos, right? Hence, uy is going to be v sine theta and uh is going to be v cos theta. I believe you get that part. Right?
Yes, sir.
Say something, people.
Yes, sir.
Yep, sir. Got it.
All right. Now, question, right? What happens to the velocity of an object when it's been projected upwards? Does the velocity increase or does it decrease?
It decreases.
Right? It decreases. Right? Now, what causes that decrease in velocity?
Gravity and the weight.
Right. So let's say gravity, because remember the weight is because of gravity as well. Right? So yes, the gravity causes the what is this? Causes the velocity to decrease, right? Remember, remember what acceleration represents, right? Acceleration is the change or is the rate of change of what? Of velocity, right? So if we have gravitational acceleration as 9,8, right? So for engineering science and for specifically, right, G is going to be equal to the magnitude of G we are going to use 9,8 meters per second squared, right? What this essentially means is that the velocity of the object, right, whether it is increasing or decreasing, is going to change by 9,8 meters per second every second, right? So essentially, that is what influences the velocity of the object in the vertical plane. Seeing that in the vertical plane, we have some form of acceleration, and that acceleration is in the form of gravitational acceleration, right? Now, when the object, right, leaves the ground, right, approaching the apex, right, because G is always acting downward, right? Because is always acting downward, because G is essentially opposing the object as it approaches the apex, that is essentially why the velocity decreases. Hence, when the object, is going up, because G is opposing the object or opposing the motion, then we take G when the object is going upward as being negative. Are we clear here?
Yep.
Right.
Yes, sir.
Hence, when the object reaches the apex, right, what happens to the velocity of the object there in the vertical plane?
Decreases.
So at the apex, remember, you have the velocity, it gets projected, it approaches the apex, it reaches the apex, right? When it reaches the apex, what happens to the velocity of the
But
object
the,
in the y plane?
the vertical velocity gets to 0.
Yes, exactly. Right. So at this point, the velocity or the components of the velocity in the y-axis or in the y plane, right, it becomes 0. Right. Now, we've already established what influences what is this velocity, right? In the y plane, what's going to influence velocity is acceleration. That acceleration is in the form of gravitational acceleration, right? Now, what is going to influence the velocity in the horizontal plane? Taking into consideration that the only quantity that influences velocity is acceleration, right? So the question is, what's going to influence the velocity on the horizontal plane?
It's going to be the initial velocity and the angle at which the projectile is being projected in the horizontal plane.
Say again?
The factors that are going to influence acceleration in the horizontal plane is going to be the initial velocity at which this object is projected, as well as the angle at which it is projected horizontally.
Right. So my question was, what is going to influence the velocity, not the acceleration? What is going to influence, essentially, what is going to influence UH, right? Remember, we've already established that what influences the velocity in the y plane is what? Is gravitational acceleration, right? We said when the motion is upward, because the motion is upward and opposes G, we take G as being negative, right? So meaning that is why the velocity in the y plane, when the object is still approaching the apex, that is why it decreases. It increases from the apex going downward, right? Why? Because in that case, the motion is in the same direction as what? As G. Hence, we take G as being positive. Hence, the velocity increases. Either way, though, the only quantity that is influencing velocity is what? Is acceleration, right? Now, do we have acceleration on the horizontal plane?
Yes, sir.
Yes.
We have it. Where is this acceleration coming from? Because on the vertical plane, we know acceleration is gravitational acceleration, right? So if we have acceleration on the horizontal plane, where is it coming from?
Is it maybe from a force that's being applied or something?
Which force? Remember, this has already been projected, right? For there to be a force, the reason why I said, someone said what influences the velocity is the weight, and I disregarded the weight because the weight is based on G anyway, right? Now, weight is equal to what? M times G, right? Hello?
Yes, sir.
Yes. Yes.
Right. So this is from the perspective of the vertical plane, right? Now, in the horizontal plane, we still have M times G, but now it becomes F net is equal to MA, right? On the vertical plane, this is what we have, right? Based on what? Based on G. On the horizontal plane, do we have F net? We can only have F net if we have acceleration. Now, if you have acceleration, where is it coming from?
Gravity.
So it can't be gravity. Is that right?
No, we don't have acceleration in the horizontal.
Exactly. There we go. We do not have acceleration. We do not have acceleration on the horizontal plane, right? Essentially, what tends to happen is as the object is approaching the apex, right, on the horizontal plane, the object moves using its own inertia. Do we remember Newton's first law of motion? The law of inertia, right? Essentially, the object uses its own inertia to propel itself forward in the what? In the horizontal direction, right? Hence, because there is none of this, right, the velocity in the horizontal direction remains the same. Are we clear here?
Yes, sir.
Right? So essentially, the object propels itself forward using its own inertia because there is no external force propelling it forward. Because there's no external force propelling it forward, right, F net is equal to 0. Hence, the law of inertia. So this propels itself forward using its own inertia. So meaning, as far as the velocity in the horizontal plane, it remains the same throughout the object's motion until such a time that it lands. Are we clear here?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So that is essentially how we look at what is this projectile motion if the motion is such that it is making somewhat of a parabolic shape, right? Now, let's take the initial point as A, take the apex as B, take the landing point as C, right? So essentially the object moves from A, gets to B, and then goes to C, right? Now, the time it takes for the object to move from A to B, right, is going to be the same time it is going to take for the object to move from B to A. Agreed?
B to C, sir.
B to C, yes. So from A to B, the time it takes for the object to move from A to B is going to be the time it takes for the object to move from B to C. Are we in agreement here?
Yes, sir. Yes, sir.
Right? So essentially, if you have time AB will be equal to what? Twice. What is this? Time AB. Okay, yeah. Let me say. So if you have time AB, then time AC will be equal to what? Twice of what? Of time AB. Are we in agreement? That is what we just said just now.
Yes, sir.
That the time it takes for the object to move from A to B is the same time it takes for the object to move from B to C, meaning that from A to C is essentially 2 times what is the time it takes for the object to move from A to B, which is this here. Agreed?
Yes, sir.
Right. Right. And then as far as the apex, right, that is depending on the angle, right, this is the maximum vertical displacement or maximum height that the object reaches, again, based on what the angle is and what the initial velocity is. Are we still together?
Yep.
Yep.
Sorry,
Yes, sir.
that time equation, doesn't that 2 then mean that it's double it takes double the time?
Second.
2 on top the time AC.
So what about this?
That 2 there, doesn't it mean AB then takes 2 times the length of AC.
2 times the length. No.
Oh, wait. Never mind. Sorry, I see what you
Okay.
mean.
Okay. All right. Now, as far as the equations that you can expect to use here, right, for projectile motion, it is these ones, right? Still the same as the equations of motion, right? I've just denoted them differently, right? Under what is this equations of motion? We know V is equal to U plus AT, right? Now, specific to projectile motion, if the projectile is such that it is parabolic, then this is what we are going to use, right? Vy is the final velocity of the object, right, at the apex, right? So the velocity at this point, right, we call Vy, and the initial velocity we call Uy, U for initial, V for final, right? So hence here, because this is final, I've denoted it as Vy, this as Uy as the initial plus GT, right? And then, of course, the other ones as well, right? Now, as far as which equation of motion to use, you use the one that is convenient for you to use. The one that is convenient for you to use will be based on what you've been given or and what you are looking for. Are we clear?
Yes, sir.
Yes, sir.
Right. Now, on the vertical plane, you can use any one of the equations of motion, right? But on the horizontal plane, right? On the horizontal plane, we can only use essentially this one. Why? Because we do not have acceleration on the horizontal plane. The object moves or propels itself forward using its own inertia, right? So meaning we cannot use this one, cannot use this one, cannot use this one. Hence, we can only use this one, right? And because essentially the velocities are the same, right? We take this as the average velocity, right? So for calculating, or the only equation of motion we can use for the object on the horizontal plane is this one here, right? Displacement, or the horizontal displacement or range, is equal to UH, which is the initial velocity on the horizontal plane, UH, so the V cos theta, right, times the time it takes for the object to move from A to C, which is equal to what? Twice the time it takes for the object to move from A to B. Are we clear here? Yep. Hello.
Yes, sir.
Yes.
Right. Now, for now, I would suggest that you guys stick with using the equations of motion as it is, right? I don't want to confuse you too much about how we get to this here, right? So this, for instance, um, say we want to calculate time, right? Say maybe the question is, what time does it take for the object to get to its maximum height or the apex, right? Now, the most convenient, the most convenient equation of motion to use would be this one, right? You'll be given the initial velocity, hence you'll be able to calculate the component of the initial velocity in the y-plane. So you'd have this. This, you know, is equal to 0, which is the velocity at the apex, final velocity, right? G, you know, is equal to 9,8, right? For engineering science and for specifically is 9,8, right? Make sure when having to do when having to write a test that you go through your instructions, right? That is where you will get an indication as to how to take your G. If you must use your G as 9,8 or 9,81. But predominantly for engineering science and for, we use G as 9,8. Right? For mechanotechniques, it is always 9,81. Are we clear? Yep.
Yes, sir.
Right. So if you have to calculate the time it takes the object to reach the apex, you know that's 0. You have this, you have g, you calculate time, right? Now you know the time that it takes the object to reach the apex, you're going to take as what? As AB, based on this drawing here, right? Since we've labeled the initial point as A and the apex as B. So essentially they're looking for TAB, right? And because of that, taking this equation, solving for T, right? Remember that this is going to be negative. This is 0, so you take this, that side, and essentially you'll have GT is equal to UI, right? UI being the vertical component of the object in the y plane, right? Or the initial velocity of the object in the y plane, right? Being what? Being v sine theta. That is how we get this equation, right? When solving for the time in this equation of motion, right? But again, this you will get to use once you get used to doing problems based on projectile motion. For now, just use the equations of motion as they are. Are we clear?
Yes, sir.
Yes,
Right,
sir.
right. But I should mention that it is convenient, right, to know these equations as well. It saves a lot of time, right? But it can be a bit tricky if you're not used to doing problems based on projectile motion, right? If you can get to this, right, I'm fine with it. You can use these equations. These equations come from these ones here, come from the main equations of motion, right? So again, you can use them at your own risk. Are we clear?
Yes, sir.
All
Yes,
right,
sir.
let us look at an example. Let us look at an example. Right. Right. Let us consider this example here. Right. Right. Let me just fix this quickly. All right. Right. Now let's see what we have here. A stone is thrown at a velocity of 29 meters per second at an angle of 35 degrees. Right. So this is being projected at an angle of 35 degrees, right, to the horizontal. Right. So our 35 degrees or the angle of projection is reference from the horizontal axis or the x-axis. Right. Calculate the following. Now let us see what we have initially. Right. We have an initial velocity which is 29 meters per second. Right. So as you know, because this is being projected at an angle, we have to resolve it into its components. We are going to have the vertical component and we are going to have a horizontal component, UH, right? And then we know at this point, we have at the apex, we have Vy, and our Vy we know is equal to 0 meters per second. Right, this is 0 meters per second. And then the UH, because the object is essentially propelling itself in the horizontal plane using its inertia, UH remains the same until such a time that the object lands. Right? And then, of course, this here will be our SY or our H max. Right? So that's the apex. Right? Now, what is UH equal to? UH being in the horizontal plane will be what? The initial velocity is 29 meters per second. So this will be 29 cos theta. Theta is 35, right? And then UY being the vertical component will be 29 sine theta. Theta being 35. Right? Are we in agreement here?
Yes, sir.
Right. Now let us look at the questions. Right. Let's calculate the following: the maximum height that the stone reaches. Right. Easiest way of doing this, we know that's A, call this B, and call this C. So if they want the maximum height, right? They want, this is what they want here, the maximum height. Right. Now, based on what we've been given, right, we have, because essentially we're looking at the vertical plane, so we are going to make use of the vertical component, right, as opposed to having to use the horizontal component, right? So looking at the vertical plane, in the vertical plane, we are looking for H max. We have Uy, right? So we have the initial velocity. We also have the final velocity, right? Now, based on that, which equation of motion would you say is convenient for us to use here?
Number 4.
Number four is S is equal to, so number 4 is Vy squared is equal to Uy squared plus 2G, call this Sy or H max. Is this the one you're referring to?
Yes, sir.
Right. Yes. This is the most convenient one. We have Vy, we have Uy. We are looking for this. We have G. So essentially, we have everything we need here to get what we are looking for. Right. Now, Vy we know is equal to 0. So that's going to be 0 squared is equal to Uy. Uy is, as we've established, 29 sine 35. So all of this squared plus 2 times. Now, G. Is G positive or negative? Hello?
Negative.
Right. So because G is opposing motion, you're going to take G as being negative. So this is 9,8, right, times Sy. Right. Obviously, what we'll get here is going to be negative. Now, what is 2 times 9,8? Let's go, people.
19.6.
So that will be negative 19,6, right? So we then transpose that to this side. Hence, it's going to become positive 19,6. Sy is equal to 29 sine 35, right? All squared. We are looking for Sy. So we divide both sides
Okay.
by 19,6, right? Obviously, that cancels. And then we get our Sy or H max. So what is this equal to? Remember, everything, right? Everything in our numerator is squared.
It's 14.116. Sy will be 14.116.
So this is 14,116. Is anyone getting anything different? So everyone is getting the same thing.
Yeah.
Sir.
Yes, sir.
Okay, you guys can use your calculators. Beautiful, right? So that becomes
Sorry,
our,
sir.
yes.
I am getting 9.541.
Sir, it means you cannot use your calculator, sir. So in using your calculator, né, in using your calculator, do this. Open brackets, place the 29 sine 35. Remember, there's a bracket that's going to open here, right? And then you put another bracket, then you square, right? And then, of course, divide by 19,6.
Oh no, I didn't divide. I see now my mistake now.
All right. So everyone is good here.
Yes, sir.
Sorry, sir.
Yes, sir.
Right. So that's our HY or H max, right? This is so this was 1,21. So 1.21, right? Now let's look at 1,2.2. They want us to calculate the horizontal displacement or range, right? That's the one thing I forgot to label here. Horizontal displacement or range, right? So that is what they're referring to, right? The range is the horizontal displacement covered from the initial point to the final point, right? Now this one, so this is 1.2.2, right? Because we're looking at motion on the horizontal plane now, we know there's only one equation there of motion, which is SH is equal to what? UH times TAC, right? Hello?
Yep. Sorry, sir. Could you scroll back up to the question, please? Thank you. Horizontal displacement. Okay.
Right. So are we in agreement here? Because we're looking
Yes, sir.
at the horizontal plane, we know by now that when looking at motion on the motion of the object on the horizontal plane, we make use of just one equation of motion, which is this one. Right. So we look at the initial velocity, in the horizontal plane, right, multiplied by the time it takes the object to move from its initial point to its final point, right? Now we have already established, this is what we're looking for, UH. We've already established that TAC is equal to what? Is equal to 2TAB, right?
Yes, sir.
Right. And what is TAB equal to? From this equation of motion, V is equal to, so this is Vy is equal to Uy plus, what is this? GT. Remember this equation of motion, right? From this equation of motion, we are able to get TAB, right? Are we still together?
Yes, sir.
Right.
Yes,
We
sir.
know
Yes,
that
sir.
Vy is equal to 0. UH is equal to, what is this? 29 sine 35, right? Plus G, right? Remember, at this point, we are still looking at the object from the perspective of it approaching the apex. This is TAB, right? So at this point, G is negative. So this is negative 9,8 times TAB, right? So essentially TAB is equal to what? Right? We take this term, transpose it to that side, it becomes positive. So maybe let me do that instead. Right? So transpose this to that side. This side, it becomes positive 9,8 times TAB is equal to 29 sine 35, right? And then to get TAB, right, you divide by 9,8 both sides. So TAB is equal to 29 sine 35 divided by 9,8. Now, what does that tell us? That tells us that in the part of the motion where the object moves from its initial point to the apex, right? So from A to B, the time there, right, TAB is equal to what? Right? Remember, 29 meters per second was the initial velocity, right? So that's V sine theta divided by, so essentially G, right? Divided by G. Are we in agreement here?
Yes, sir.
Right. So from here, you can say this is equal to UH, right? Let's say UH we know is equal to V cos theta times 2 times TAB, which is equal to this. So this then becomes times V sine theta divided by G, right? So essentially SH is equal to, now what you have here is you have V times V, which is V squared. So this will be V squared times, this becomes 2 sine theta times cos theta divided by G, right? Who remembers what is this double angles? The identities for double angles, right? This here, the 2 sine theta cos theta, right, is a double angle identity, right? And it is also equal to, right, so the 2 sine theta cos theta can be replaced with its identity, right, which is sine 2 theta divided by G, right? So whenever you get such a case where the time hasn't been given and you don't necessarily have to calculate time, to get the range or to get the horizontal displacement, you can simply just use this equation here, right? But now if this equation is too complicated, you can simply just substitute at this point. Are we clear here?
Yes, sir.
So
Right. So essentially, SH, right, SH is equal to V squared. Our V is 29 squared times sine into 2 times theta. Theta is 35 degrees. All of this divided by 9,8. And what do we get here? What do we get here? Hello? What are we getting?
For me, sir, I'm getting 80.641.
80,641. 641 meters. Is everyone else getting the same thing?
Sir, but I'm getting 104.82.
Something is off there. Recalculate, my guy.
I'm also getting 80.601.
Yeah, 80,641 is correct.
80.641, yeah.
Yeah.
I did something wrong. Okay.
Yeah, just recheck your calculation there. Right. So if you substitute your values, right, at this point, you are going to get more or less the same thing. So it doesn't really matter how you approach it. This one is just much quicker because you know by now that you can use this. So in starting your problem, you can simply say SH is equal to this here, as opposed to having to take it through these steps. You can simply say SH, or the range, is equal to V squared sine 2 theta over G, and then substitute. Are we clear here?
Yep, sir.
Right. But again, it also depends on what you've been given and what you've been asked to calculate. Right. So we took this approach based on what we've been given. Right. So because we weren't necessarily given time, that is why we made use of this equation here to substitute here.
Yes, sir.
Right. Any more questions?
So what is it?
Yes.
Could you please go up on the drawing? Sorry, sir. We were asked to calculate the distance from A to C, right? The
Yes.
range. So the time we take to A to B, that was around 1.6, if I calculated right, 1.697. Then are we not supposed to double that time that we can reach all that that distance to C? You said the time that we take from A to C is double
Yes.
from the one it's A to B. Yeah.
Yes.
So I think that if we were doing that way, I think that 80 point something, we have to times it, because it is the distance from A to B, not a distance from A to C.
Right. Take note of this here. Right. This we said 2 times TAB.
Yes, sir.
So we've already accounted for that. When we say 2 times AB, because seeing that the time it takes for the object to move from A to C is double the time it takes it to move from here to there. Not the distance, the time.
All right.
Right. Hence we said here, because we're looking for TAC, and we've already established that TAC is equal to 2 times TAB, right?
Yeah.
And then we substituted what TAB is equal to, and TAB is equal to V sine theta over G. So we've already, essentially, when doing this here, it is us accounting for the fact that it takes 2 times AB to get to AC, or to get to C.
All right.
Yes. Any more questions?
No, sir.
Right. I will be sending you a document with exercises based on projectile motion. Right. I will highlight the ones that you guys must look at that will be relevant for the test. But I'll also be sending you ones for what is this? Beams. Are we clear here?
Yes, sir.
Now
Yes,
regarding
sir.
beam, so this is the document I'm going to send you, right? Take note of this, right? You are going to look at number 5 here. Right, you're going to look at number 5, as in question 5, the one I've just highlighted. We're going to look at this question 4, right? And then you can look at as well this question 5 here, right? So you can look at these 3. If you're able to do these 3, then you should be fine tomorrow. Are we clear?
So
Yep, sir.
And just so we are clear, right, on this one, right, on this question, right? This 25 kilonewtons, right, isn't necessarily there. So here you have the UDL, which is 5 kilonewtons per meter, right? Whoever wrote that 25 kilonewtons had resolved the what is this, the UDL into its weight component, right? So the 25 kilonewtons is not there. It is not a point load like 15 kilonewtons, 52 kilonewtons, and 35 kilonewtons. I will clear you. Hello.
Yes, sir.
Right. Right. In fact, seems like maybe this is going to be too much. Just do these two. Right. Question 5 and question 4. Make sure you do those two. Right. If you're able to do those two, you should be fine tomorrow. Capish?
Yes, sir.
Yes, sir.
All right. Are there any more questions? Or can we call it a
Yes,
night?
sir. What is it? Yes, man. Yeah. Hello. Yeah. Me. It's because I don't know. It's my phone maybe is updating me late. Ne? Do you still hear me? Hello.
Chief.
Yes, we can hear you.
Hello. Yeah, my phone maybe is updating me late, man. I'm trying to see your exercise, but is coming late after you pass it. Because now I'm confused. Where did you left times 2? Two times G. You see when on G on this exercise of that we are just doing it now.
Yeah.
And then now I don't see where did you left 2 on that G. See now I just see we have V2 sign.
We have 2 V sine theta over G. You mean this here?
That is where did you left 2 on that in front of that G?
There it is. There's the 2 here. There's the 2.
Oh, you cross multiply by 2. Oh, okay.
Multiply.
Okay, which means I did it wrong, ne?
You must have done it wrong.
No,
You
man.
multiply.
No, I think maybe it's my phone, man. Is updating me late on this. If even this equation, I heard you on the voice on the audio. You talk about it, but there's nothing is on my screen. I don't see anything up until past the topic.
Yeah,
Up
don't worry,
until
Chief.
when you.
Don't
Yeah.
worry, Chief. I'll be uploading this in the channel, and I'll be sending this document in particular to the group, so you can rewatch
all
the
right.
video to see what you missed.
Thank you, friend. Thank you, man. Yeah.
Sure. Any more questions?
Yes, I just want to inquire on tomorrow's test. We're going to be writing what beams, resultant velocity, relative velocity. Are projectiles going to be included?
Yes. So kinematics, the whole of kinematics, relative velocity, resulting velocity, projectile motion. The other one is beams. So under beams, you must know how to calculate reactions using moments. You must know how to draw the shear force diagram. You must know how to calculate bending moments, and you must know how to draw a bending moment diagram.
Okay, so that's it for tomorrow's test then.
Yes, it's out of 35.
Okay, thank you, sir.
Right? But if you're able to do what we've covered, or the problems that we did either on a live session or the problems you saw on the channel, you should be fine tomorrow.
Okay, thank you, sir.
Any more questions? No more questions. Wonderful. Let us call it a night. Good luck to you guys tomorrow.
Sorry, sir.
Thank you.
Thank you,
Thank
sir.
you, sir, for your help.
Sorry?
Sorry, sir.
Yes.
Yes, sir. What is the percentage pass of the test?
Alright. Make sure you get as much as possible there.
Okay.
How we clear? The last thing you want to do for engineering science is get the bare minimum.
Yeah.
So don't worry about the pass percentage. Go there and try your best to get as many marks as possible.
Okay.
Right. But as far as your case mark, test 1 weighs about 30% of your case mark, and then test 2 weighs 70%. Right. So whatever percentage you are going to get for test 1, you have to multiply it by 0.3. Right. And the percentage you get in your test 2, you will multiply by 0.7.
Okay, sir.
And then if you add those two together and your mark is above 40%, you will qualify for the exam. Capish?
Got you.
All right. Let us call it a night, guys. Good luck tomorrow.
Thank you, sir. Bye.